In section, they call it 7x, which is just extra work on factoring, because we thought that'd be useful. A couple of vocabulary phrases, and then after that we're just going to do a bunch of examples. The main focus today is common factors, so maybe at the top you might want to write down common factor or factors. And basically it means, do I see anything that goes into each of the pieces in my polynomial? So a common factor is a number or variable that goes into each term of the polynomial. And if you recall, the word polynomial means that expression that we see, something like x squared plus 5x plus 7. And then we talked a little bit about the difference of squares. When we were talking about the difference of squares, we did a lot with that in the last lesson. The difference of squares is when the polynomial has two terms separated by a minus sign, and each term is a perfect square. And the example, maybe that I could show you, would be something like x squared minus 49. Both the x squared and the 49 are perfect squares, and there's a minus sign in between them, and there's only two things. So in the common factor kind of thing, maybe an example up here that we didn't write down, so an example of this common factor thing might be something like 3x to the fourth minus 21x cubed plus 15x. And what I notice about all three of those terms is that a 3 will go into the 3, the 21, and the 15, and an x goes in x to the fourth, x cubed, and x. So those, a 3 and an x both would be the common factors of all three terms. In number 1, as I look at both the 21x and the 15, I ask myself what can divide into both the 21x term and the 15 term, and the answer is 3 goes into both of those. So 3 would be considered the common factor. Left over to produce the 21x and the 15, I would have to multiply by a 7x and a positive 5. And that's your final answer. In number 2, if I look at the 15 and the minus 20x, the thing that goes into both of those, or divides into both of those, is a 5. So I can factor out the 5, because it's the common factor. And then that means I would need a 3 minus 4x to produce what I started with. So common factors are the things that you pull out of a parentheses to begin with, and then what's ever left over in the parentheses is what you would have to multiply by in order to get back to what you started with. Okay, number 3 then. In number 3, I see an x to the fifth and an x cubed. That means the first term has 5 x's being multiplied by each other. The second term has 3 of them, so they both have at least 3 x's being multiplied. I factor out an x cubed, and then left over would be x squared, and then a minus sign, and then a 5. Because x cubed times x squared is x to the fifth, and x cubed times minus 5 is minus 5x cubed. In number 4, not only do I see that 4 goes into each of the terms, 4x squared and minus 12x, but also an x. So I would factor out a 4, because it goes into both terms, and I would also factor out an x. and then left over would be an x, a minus sign, and a 3. Because 4x times x is 4x squared, and 4x times minus 3 is minus 12x. Now sometimes, even after you pull out a common factor, there are more things that you can do. So the next few examples are going to talk to us about what more can we do if we see the common factors out, but yet inside our parentheses there's more yet to be done. Number 5, if I look at each of the pieces in number 5, I notice that a 2 will divide into each piece. So I factor out my 2. And then what's left over would be an x squared, a minus sign with a 10, x, and then a plus sign with a 16. When I see a trinomial left inside the parentheses, or even a binomial for that matter, I always still want to check, is there anything more I can do with that information? And what I will notice is that if I look at the inside of that stuff, it's like what we talked about a couple lessons ago. I see 3 pieces and I ask myself, can I write that as a product of 2 binomials? So x times x is x squared. And then I look for 2 numbers. Can I find 2 numbers that multiply to give me positive 16, yet add to give me negative 10? And the answer is, yes, I can. That would be a negative 8 and a negative 2. This stuff down below now is the stuff that happens when I look at that yellow highlight and I factor it. So my first step was to look for the common factor, pull it out, and then look inside the parentheses and say, is there any more I can do with that parentheses?
Oh, geez.
In number 6, I see that each of the terms is divisible by 3. So I factor out a 3. But then I also notice that each of them has an x. So I also factor out an x. Left over, I will have an x squared, a positive 7x, and a positive 12. Because 3x times x squared produces the 3x cubed, 3x times 7x is 21x squared, and 3x times 12 is 36x. Then I go back to that inside of the parentheses stuff and say, is there anything more I can do with that stuff, which was our first lesson in chapter 7 about factoring. Not common factoring, but just straight up binomial factoring. When I look inside of that, if I try to do that, I would have to have 2 parentheses, and I know that there is an x times an x that produces the x squared, and then I would ask myself, what 2 numbers, if I could do this, could I multiply to get 12, but add to get 7? And the answer is positive 4 and positive 3. So your final answer is that last line, which also took that yellow highlighted stuff and factored it to get the binomial factorization in the green highlight. In the last 2, we'll discover something kind of interesting. In last one on the slide, that is, in number 7, I see 2 things. But before I do anything with those 2 things, I ask myself, is there anything that can go into both a 4 and a 64? What? 4. So I pull out the 4, and left over, I still have an x squared, because 4 times x squared is that x squared. There's a minus sign, and 4 times 16 is 64. And then I look inside here, and I notice from our last lesson that this thing is something special. It's called the difference of 2 squares. And if you remember, when we have the difference of 2 squares, that means I still have that 4 on the outside, but this yellow highlighted parentheses is actually x plus 4, x minus 4, which was what we talked about in the last lesson, something called the difference of 2 squares. So the yellow highlight turns out to be this green highlighted stuff, and you still have to keep going until you get to that green highlighted stuff. Difference of 2 squares. In number 8, it's something similar to number 7. So as I do number 8, what I see is that in 36 and 100, there's a number that goes into both. 4. So I write down my 4, and left over is a 9x squared and a minus 25. And then as I look at the thing that's on the inside, I say, is there anything I can still do with the stuff that's on the inside? And the answer is yes. Both 9x squared and the 25 are perfect squares, and there's a minus sign in between. That means that we have another difference of 2 squares situation. Square root of 9 is 3. The square root of x squared is x. And the square root of 25 is 5. So I will have 3x plus 5, 3x minus 5 as the finishing off of the factoring of the difference of two squares. So on this next slide, we look again, as always, to see if there's a common factor. But this slide is more dedicated to things where you don't have a simple x squared in the front. And these tend to be more complicated. When you see something like this where you have a trinomial and you're trying to factor it, thinking about the last thing and the middle thing as what adds to this and what adds to that and multiplies to this doesn't always work so well. So then it's about experimentation and seeing what you get when you try to figure